All right, tonight we're going to be looking at equations of lines in a coordinate plane. This is stuff that you should be really familiar with already, so feel free if you just know something to skip through certain parts of the video and to move on to other ones. I will not be personally offended by that. And so you'll come into class tomorrow and this is all we're working on. So we'll be focusing on this. So the first thing we're going to look at before we get right into the equations is slope. And what exactly is slope? Well, slope is the rate of change. This is its official definition. Vertically, if I can spell right, over horizontally. So that's to put it in official words. So you may not have seen this denoted quite this way before. That would be that triangle means rate of change. So that would be the rate of change vertically are in the y's over the rate of change horizontally. Oops. I'm not doing too hot spelling today. All right, there we go. A more familiar way to put this would be rise over run. Okay, and then the formula we have for slope, remember we denote slope m, would be y2 minus y1, so the difference in the y's, over the difference in the x's, x2 minus x1. Okay? So those are that's what slope is, and that is our equation for slope. So let's go ahead, I'm going to go back to this real quick for a second, and look at an example of finding slope. So let's just say, for example, I have this line, we'll call it AB, where A is at 2, 3, and B is at 0.57. And I want to find the slope of AB. So to do that, I could just plug it into my formula. Call one of my points my x1, y1, one x2, y2, and just go. So for instance, that would look like y2 minus y1 over x2 minus x1. So I would get 7 minus 3, which is 4, over 5 minus 2, which is 3. So my slope for line AB would be 4 over 3. Okay? So what I want to do now is look at the different forms of linear equations we have. The first and most commonly used form is slope-intercept. Slope-intercept form is y equals mx plus b. M and b here are what has to be known in order to graph this line, in order to find all the points that go through this line. We need to know m and b. M again is our slope. B is our y-intercept. And remember, y-intercept is just where that line crosses the y-axis. Okay? The next form we're going to look at some today is called point-slope form. For point-slope form, you need a point of your line, and then you also need the slope of your line. So exactly what it sounds like. So that formula is y minus y1 equals m times x minus x1. Okay, so here again we have m, which is our slope. And then we have a coordinate x1, y1, which is just a point on the line. So that form we don't use as much, but we will be using it a little bit. And then the last one is standard form. So the standard form of a line is simply ax plus by equals c. Okay, So on this one, A, B, and C just stand for constants, and X and Y are variables. They are points on the line. Okay. So let's look at some examples of graphing a line, given it in different forms. We're going to look at slope-intercept and then point-slope. So let's look at part A. We want to graph the line y equals 3x minus 4. So there are two very important numbers we need from this. We need our slope, and we need our y-intercept. Okay. So when you are graphing a line that is in y-intercept form, or slope-intercept form, the easiest way to do it is to first graph your y-intercept. So our y-intercept is negative 4. So we're going to go down on the y-axis 4 and make a dot. Okay, so that little red dot there, that is my y-intercept. That is where that line is going to cross the y-axis. And then you can use your slope to make another point on the line and just connect those. So our slope here is 3r/3/1. So if that's rise over run, we're going to go up 3. So we'll go up 1, 2, 3 over 1. Okay, because that was a positive slope, and make another point. So that other red point would be another point on our line. And then once you have 2 points, all you need to do is connect those. I am going to ask that you use a ruler to do that. To connect your lines when you're doing those. That's a little crooked. There we go, that's better. All right, so that is our line for this one. We'll call that first one line A. So now let's see if we can graph, we'll call it line B. So for line B, this is one that is in slope-intercept form, or sorry, point-slope form. So the easiest way to do point-slope is to graph the point you're given, and then to use your slope to get another point. So let's see if we can figure out what our point is from this formula. Remember, point-slope form is already negative. So our point here would be 4, 2. Okay, so we're going to graph the point 4, 2, which is right here. And then we're going to use our slope, which is negative 1/3, to graph another point. So since it's rise over run, I'm going to go down a negative 1 and then over a positive 1, 2, 3 and make another point. Okay. Once I have 2, again, I can connect those using a ruler with a straight line. So that blue line there would be my line B. All right, so that is graphing a line, and we'll go over that some more tomorrow if you're having issues with it. All right, the next thing we're going to do is look at writing the equation of a line. So here, let's look at part A first. We want to write the equation of a line with a slope, which is an m, of negative 1/2, and a y-intercept, 1/2, and a y-intercept, which is our b, of positive 2. So since we're given slope and y-intercept, we're going to want to use slope-intercept form, which is y equals mx plus b. And all we need to do is plug in our m and b, and we will have our equation. So y equals m, which is negative 1/2, times x, plus our y-intercept, which was 2. Okay, so that would be the equation of our line. Remember, we use x and y there because there are an infinite amount of points on a line, so x and y are our variables. The slope will always be negative 1/2 for that line. The y-intercept will always be positive 2 for that line, but the x and y are going to change. So now let's look at part B. For part B, we want to find the equation of a line through point negative 1, 4. So here we're given a point and a slope, our m, of negative 3. So since we are given slope and a point, we're going to want to write this one in point-slope form, which is y minus y1 equals m times x minus x1. Whoops. Okay, so to plug in our information, we have y minus the y of our point, which is 4, equals our slope, which is -3, times x minus the x from our point, which is -1, so that just becomes +1. And that would be the equation of our line in point slope form. We could take this and solve for y. If you were to do that, then you would have slope intercept form. Okay? The next thing we're going to do is writing the equation of a line given 2 points. So here we're missing a little bit of information. So for any of our equations, we need slope. We need to know what m is. So remember, slope is y2 minus y1 over x2 minus x1. Okay, so the slope of this line, we'll call that x1, y1. We'll call this x2, y2. And you do not have to label these. I'm doing it just in case you need it. So that would be y2, which is -1, minus our y1, which is 5, over our x2, which is -2, minus 3. So that would be -6 over -5, which would be positive 6 over 5. So that would be the slope of this line. Once we have the slope, we can just put it in point slope form. Using either one of our points, I'm going to go ahead and use x1, y1, since that is what is in our formula. So that's the one I'll use. So plugging in that point, we get y minus our y1, which is 5, equals our slope, 6 over 5, times x minus x1, which is 3. So that would be the equation of our line in point slope form. Again, it would be very easy to solve this for slope intercept form. All we would need to do is add 5 and distribute the slope and then combine like terms from there. All right, last example. I'm going to look at the equations of a horizontal and vertical line through the point for -3. First of all, let's look at our slopes and the direction our slopes are going to have. That'll help us complete this problem. A positive slope will go up from left to right. So if there was a man, he'd be going up a hill from left to right. A negative slope will go down from left to right. A zero slope would go straight across. It would be horizontal line. So a zero slope would be horizontal. And then a undefined slope would be a vertical line. It would be straight up and down, okay? So that would be undefined slope. So for a horizontal line, you are going to have the equation y equals something. So some number. For a vertical line, you would have the equation x equals something, some point. So if we are wanting to find the horizontal and vertical lines through 4, 3, -3, we know that the horizontal line is going to be y equals something. Well, in our case, y equals -3, so the horizontal line will look like y equals -3. The vertical line we know is going to be x equals something. So in our case, our point is at 4, so the equation of that horizontal line would be x equals 4. Okay, so that is a horizontal and vertical line. So what we're going to do tomorrow in class, we're going to work on this. We're also going to look at our graphing calculator a little bit, figure out how to find slope in a graphing calculator, how to graph lines, and how to find a point of intersection in that as well. See you then.